Okay, so last time we were looking at how to communicate within a VLAN but spread across different regions. So we saw how to communicate from, say, one of these two machines in VLAN 1 to one of these two machines in VLAN 1. So using this trunk approach, right, established between these two switches. But this trunk approach doesn't help us to communicate between a machine in one VLAN to a machine in another VLAN. So for example, we can try to ping to 192.168.20.11. We cannot, we won't get the reply, right? So with the trunk approach, we will be able to communicate only across between machines that are in a single VLAN spread across multiple or across different switches. But if you want to communicate between machines from one VLAN to another VLAN spread across different switches like this, we won't be able to communicate as it is. So basically, when you want to communicate from one VLAN to another VLAN, we have to go to layer 3. With layer 2, which is this layer 2 switches, we cannot do that. We have to go use a router. Okay, so that's the motivation. So let's go ahead and see how to do that. So I'm going to quickly construct the network topology. So I have one switch here. So what we are going to do that is to, in order to communicate across VLANs spread over different switches, we are going to create a little bit more logically the topology. So I am going to put these two. So this is VLAN 1. So I'm going to let me write it, show you what I'm going to do. So I'm going to create VLAN 1 and VLAN 2. Now VLAN 1 is going to have 4 machines, 2 under switch 0. So I'm going to create the IP address to be 192.168 dot say 10.10 and 192.168.10.11. So these two are under switch 0, and I'm going to create another switch, okay, over here, and the end devices over here. So let me label them so that it's easy to keep track of things. So we will put them in a different kind of subnet so that it is easy to forward packets from one subnet to another subnet using routers. So I'll tell you that a little later. So let me put it in, let's say we'll use machines here with IP addresses 10.1 to 10.127, right? So that's subnet 10.0/25, and we'll use this from 129, so, or 130 if you want. Yeah, because we have to allocate to the server, to the gateway router. So let me use this, right? So the machines over here, right? So these two machines are basically going to have 192.168.10.0/25 prefix. So the subnet prefix. So these machines are going to basically have IP addresses starting from 10.1 to 168.10.127. 127 is going to be a broadcast address. So this is going to be the range of valid IP addresses for the machines over here. And for the machines under switch 1, I'm going to assign a subnet mask. This is the subnet address, and subnet mask is again 25. So I'm going to allocate, so this is going to be 192.168.10.129 to 192.168.10.254. So we took two addresses from this address space, right? And we're going to assign that here. So we'll go back and configure it a little later. Let me finish the topology. So now for the switches, now this is for VLAN 1. So let's do now for VLAN 2. I'm going to put this switch over here, and the PC and the devices are going to be here. So this is similarly going to be 192.168.20.10, and this is going to be .20.11. Okay, so that's going to be something like for VLAN 2, the same approach. So this is under switch 2. This will be under switch 3. So everything the same. Instead of 10 we have 20. Okay, so let me go ahead and do this on the other side also. Okay. Alright, so I'm now going to connect the things. So computer to switch, so we need a straight through cable. So let me reserve the 0/1 to connect to the router. So we will connect 0/2 this interface, and 0/3 from this computer. Okay, and let me right away put them in. They are already in VLAN 1. That's the only VLAN we have here, right? This is the VLAN 1 for these two machines. let me configure their well, we'll come back and configure later the IP addresses. Right, so now these two computers are connected to the switch, so we'll also use interfaces 2 and 3 at the switch. Okay, now these two machines, along with these two machines, are going to be in VLAN 2. So let me write it also to make it clear. So these two machines are going to be in VLAN 1. Okay, and these two machines are going to be in VLAN 2 along with these two machines, and these two are going to be VLAN 1. Right, okay, so we need to create that VLAN 2. So we go to the database, so we'll add this, then go to interface 2, so computer to switch, so we'll keep it access port. Right, so now let's connect right. Okay, so this is going to be in VLAN 1, so we don't need to configure anything for the VLAN setup. So now let's connect these two. This is going to be in Z2 and 3. Okay, now we need to create the VLAN here. So fast Ethernet, this is going to be in VLAN 2. 3 is also going to be in VLAN 2. Okay, so now we will put our router. Go for a generic router, another router R1. So now we'll need to connect a switch to a router, so we'll again use a straight through cable. I will use interface 1 at the switch, and for this interface switch 0, we'll use fast Ethernet 0, 0. So let me write it over here to keep it simple. And I'm going to assign an IP address 168.10.1. Okay, so routers always get the first available IP address in an address space. So we'll use this, and on this, let me connect this to this. So this is going to be FA 1/0 and 20.1. So this switch is going to be in 0, 1. This interface is VLAN 1, whereas this has to be in VLAN 2, right? Because there's nothing to do with VLAN 1 as far as this switch is concerned. Both its computers are in VLAN 2. Alright, so this, I configured this side of this to be in VLAN 2. Similarly, this guy is in VLAN 1 from this side. Now let's configure the routers. This router. So let me put no. So let's get into the root mode. So we want to configure the terminal interface. We want to configure fast Ethernet 0/0. You can even do like this, FA 0/0. Okay, and I want to set its IP address be 192.168.10.1 with a subnet mask. Now the subnet mask is going to be what? It's going to be a 25-bit subnet mask, right? So so it's a 25-bit subnet mask. So it's going to be 250, which means 25 ones, right? So 255.255.255 is 24 ones, followed by last one, the 25th one, 7 zeros, right? So this is 8 bits. Okay, so that's going to be what? 128, right? So if someone takes a bitwise AND between the machine over here, say 192.168.10.10, with this, they are going to get what? 192.168.10.0, right? So that will forward to this side. Okay, so the subnet mask has to be what? It has to be 255.128, right? On the other side, so let me exit. Oh, we have to turn it on, right? So otherwise it will keep staying red. So let me go back to that interface. So we have to run no shutdown to turn it on, so it will turn to green now. So let's now exit, go to this interface. You can even say INT for interface, but if you want, you can press a tab, you'll get interface FA1/0. Now I can say IP address 192.168.20.1, and the subnet mask is going to be .128. Then say no shutdown to turn it on, right? So you can exit, do one more exit, and let me say show IP route and see what it says. So the 10.0 and 20.0, they are located on this subnet, right? So as it is, you could ping, but we have to configure the machines with the IP addresses first, right? We didn't do that yet, so let me do that. So this machine is going to be 192.168.10.0, sorry, 10.10, right? And the default gateway is going to be this router, so 192.168.10.1. So you don't need the DNS server. And let's do the same thing here. Okay. So the default server gateway service 20.1 or VLAN 2. Okay. Alright, so now I can ping ping 192. So we are at 10.10. So let me first try with the same VLAN machine, 10.11. So I'm able to ping. So now let's try with 20.11 and see what happens. So it takes a while to find out the MAC address, right? And now if you run it again, you should be able to find it, get the reply right away for the first request itself. Let's try 20.10. It may take a while, and you should be able to get it, right? Let's try here from one of these machines. So you see here a router has to be involved to communicate across VLANs, different VLANs. So ping 192.1, here 20.11. Let's try to ping to 10.11. Okay. What happens is, because you want to send to 10.11 from 20.11, right? So since you're in different network prefixes, this is in 20.0, right, and this is 10.0. This PC has to forward it to the gateway router. The gateway router looks at its routing table, and I just showed the routing table, if you remember. It says 10.0 is in this fast Ethernet 0/0 interface, so it will do a bitwise AND of 10.11 with this 255.255.128, and you get 10.0, right, like I showed just now, right? So if we do it 10.11, you'll get what? 192.168.10.0, and that corresponds to this interface connected to fast Ethernet, this interface FA00. So it sends it to the switch, and the switch knows the MAC address, so it sends to 10.11. Okay. So if you want to send a packet to a machine outside your VLAN, outside your network prefix, you have to go through a gateway router, right? Or layer 3 communication, basically. So let's do the same thing over here. So what we have to do is, so first we'll enable communication between these two VLANs within this router's management, and then within this router management, and then between these routers. Okay. Alright, so let's see what we're supposed to do here. We will connect these two switches to the router. So let me start with this guy. We take up this interface. Okay. So I'm going to label it. This is FA0/0 of IP address. So the first available IP address in this address space is what? Told you it is going to be 128/25 is the kind of subnet address. So 129 to 254. So the router always gets the first available address in an address space. So this is going to be 10.129, right? And this interface is going to be okay, 10.129. So now let's configure this router. Enter no, return, enable to get into privileged mode. Then what you're supposed to do, config T, right, then interface FA0/0. So we'll configure now this terminal, right? This interface. So IP address 192.168.10.129, and this is a 25-bit subnet mask, so this is going to be similarly 255.128, right? Okay. Okay, and let's say no shutdown. All right, and let's configure the other side. Okay, and let me say show IP route, and you can see here so since we had 10.129, right, we configured as this router's IP address. So the subnet mask is going to be 10.128 on this side and 20.128 on this side. Okay, so the routers get always the first available IP address in an address space. Okay, so that's good enough. So let's go back and configure this PCs. So that is 192.168.10.130. We need to change a subnet mask, right? So it has to be 128, right? Even in the other cases, yes. So this is going to be the default gateway, right? So before I forget, let me change the subnet mask. This has to be 128. It didn't make a difference here because we started with from 0, that subnet, to 126, right? But for the other one, if you want to really communicate from this 1 to 128 subnet to 129 to 254 subnet, we really need to change it. Okay. All right. So now let's configure these routers, these computers. Okay, so check. So this is VLAN 2, right? So I need to make this interface of the switch, the first interface FA01 has to be in VLAN 2, right? So already created the two VLANs, and I think that should do. Right, so let me start testing from here. So I want to ping to this machine, it works. Right, so now let's try to ping to 20.131. Okay, so it takes a while to get the MAC address and then it works. 20.130. Right, so that's done. We could test one more machine. So ping Right, so why it works? Because this is configured to the 110.128 subnet, right? So the router does a bitwise AND with the subnet mask, that is 255.255.128, and then finds out a match and sends out on this interface, right? So now let's do, I think it's clear, right? So I wanted to send to whom? I wanted to send to 192.168.10. say 130. I do a bitwise AND with my own subnet mask for that network, for this machine, because you want to send from this machine, right? So for that, the bitwise subnet mask is this. So that gives me 192.168.10.128. So it figures out it is in a different prefix because this machine is in 20.128 prefix. So the destination is in a different prefix. So this PC has to send the packet to the gateway router. So the gateway router gets it, does a bitwise AND like we did, and finds out that this is the subnet prefix it gets. And this guy 110.128 is in this interface, right? That's what we did by running the IP route command, show IP route command. 10.128 is directly connected to fast Ethernet 0/0, and it then forwards a packet to this machine, right? So now let's try to connect these two routers. So to connect a router to a router, we need a serial cable. So we'll go to serial DCE, click on this router, pick serial 2/0, connect it to this serial 2/0. The configuration is very similar. So we'll go to config terminal, and then now we will configure the serial interface 2/0. So you can do a shortcut command like this, or interface serial space or no space 2/0. And for serial interface we typically give a 10.0 IP address. So let me give this interface 10.0.0.1 IP address, and this interface gets a 10.0.2 IP address. Let me move it here. Okay, so we are going to give this interface 10.0.0.1 with a subnet mask of what? 8 bits, right? So 255.0.0.0. Alright, so from the subnet mask, the router is able to figure out what is the subnet address for that interface. Now you have to turn it on, no shutdown, but the other side also has to be turned on, okay, before it changes to green. So you can exit from here. Okay, so let me go back and turn on this interface, and then we have to do some configuration. So config terminal interface serial, this is also 2/0. Now IP address on this side is 10.0.0.2, and this is also going to be the subnet mask. Okay, alright, so now what we have to do is you have to also turn on. Okay, so that turns this to green. So let's go to this router and we need to configure the routing table. Okay, and we do that from the global configuration mode. Okay, so if I want to send to a 10.128 network, right, I need to send to this guy as the next hop. Once this router gets this, I'm looking at this router's point of view, router 0. When this router, okay, router 0 gets a packet from one of these machines that has to go to a 10.128 network, which is this network, to one of these two machines over here, it has to send to this. From here it has to go to this next hop, and when this router gets it, it will do a bitwise AND like it did for the packets coming internally from this switch, and figure out that the machine is in this interface and will forward down. So what we have to do is we have to say IP route, that's the command syntax, IP route, then the destination network address or subnet address 10.128, right? This is the subnet address, 10.128 prefix this side, right? So how do you state that it is a 10.25-bit subnet mask, right? So I have to say this is 128. Okay, so this tells you that the first 25 bits for network and subnet, and this is a subnet address 10.128, right? And what's the next hop? 10.0.0.2. So this is the syntax. So packets going to this network address, right, or subnet address with this subnet mask 25 bits should be routed to, this is the next hop, right? And believe that is it. Now if you look at your config, if you look at the static, you can see this. Now this is only for the 10.128, of course, right? So let me go back. Now if you want to also send to this 20.128 to this network, we need to do a similar thing. So IP route 192.168.20.128. Notice I'm typing it again just to practice, okay? So don't try to keep it simple. It's the same thing almost, except 10 is 20, but I would recommend you to type it again so that you can get used to it. Okay, the commands. So this is 10.2. Alright. So now if we look at this, these are the two static routes we just configured. The other two routes it figured out when we enter the IP address command, right? Alright, so let's close this window. Let's open this router, and we want to configure the routing table. So let's come out of the interface mode. So you want to say IP route. So now it's the opposite. Anything going to this side, not opposite, this is similar, anything going to 10.0 with this subnet mask, it has to be sent to 10.0.1. Okay, and similarly IP route 192.168.20.0 10.0.1, right? So on to this router, we're looking from our router 1 point of view, it has to be sent to router 0. All right, and believe that is it. So if you look at this static, it's configured. Okay, so now let's try to ping this end host 10.130 to here 20.11. Okay, it is a success. We're able to ping it. So you can even ping to 10.10 over here on this side. Okay, so this is very good, isn't it? You're able to communicate from one VLAN to another VLAN with the VLANs spread across to multiple it's basically a wide area network, right? There are several switches, so each could be a kind of city or a department within an organization, or even a city, or a part of a city, like that, and you're able to communicate. You're able to first segregate them into VLANs. So these two computer, along with these two computer, are in one single VLAN, but they are in kind of multiple subnets though. Okay, and we went for this kind of configuration setup because we want to communicate across these VLANs using these routers. So that's why we, even though they are all in one single VLAN, we still went for a kind of aggregation, right? So everything from 1 to 126 will be in this part of the VLAN. Everything from 129 to 254 will be in this part of the VLAN. Okay, so that we can aggregate this and be able to easily create a subnet mask. Okay, so let's test it from this guy, and let's ping to something here. All right, so it works. Okay, good. So we'll stop with this.